Good morning and good afternoon, everyone. Welcome to October office hours for Layer7. This should be a good one. We're going to have actually the start of a series on how to deploy and optimize a container. With that, I'll turn it right over to Aaron and Gary.
Thanks, Bill. Welcome, everybody. Whether you're live or watching the recording, we're glad you could join us. I think, as Bill said, this content's going to be really interesting. Just a bit of preamble before I hand over to Gary, who's going to do the session today. You know, one of the things we found is with container gateways or container deployments, some of our customers are being pushed by, our gateway customers, our portal customers, the hands-on administrators, the people this call is targeted for, are kind of being pushed to start thinking about containers and where to go. And one of the things we found is that it's not necessarily a pure product requirement there. It's a knowledge, it's an enablement issue that people have. They've not been deploying things in containers, certain things deployed differently in different environments, that kind of thing. So as Bill said, we decided to start a bit of a series around that. We're going to start with some, pretty low level container stuff this week, using Docker and using the container gateway at a pretty basic level. And then we're going to build on that over the next few months and as the sessions evolve. I think one of the things that people on the call have an opportunity to pitch in here is, hey, this sort of session would be good next, right? Or that was great, but can you build on it in this way or that way? So, please put your ideas in the chat. If you've got any questions, you can obviously use the chat. If you've got any ideas for where the next topics should go, Gary's pulled together a great agenda for the next few months of what we're going to cover, but we'd love to have input from people on the call and customers and partners alike to make sure we target the right stuff. So with that, I just had a couple of quick slides or reminders I wanted to do. So Gary, can you go to the first slide? Oh, first slide is a disclaimer. We put that on everything. So just quickly, we've been busy recently. We've had some product releases. So I just wanted to make sure everyone's aware that Portal 5.1.2 came out. Gateway 10.1 CR2 actually was released twice. So, our team found, working with a couple of customers, found an issue that we wanted to fix. So we did pull CR2 for a few weeks and re-release that just this week. If you did deploy very early, you should be able to redeploy the new version on top, no problem. If you haven't, then go and look. There's some really interesting features in CR2. Go and read the release notes about what we've put in there. Some key things for sure. And OTK 4.6. So they've all been released fairly recently. Again, the documentation, which hopefully you know how to get, will tell you what's in them. The release notes. I'm not going to do that right now. But a quick reminder, if you go on our support site and register for subscriptions on the products you have, you'll get automatic emails when these things are released. And if you go to the community site and look, you'll also find out about releases, and you'll see what we're doing in each PI and that kind of stuff. So the community.broadcom.com, go and look for Layer7, you'll see cool things. And if you go to the next slide, Gary, please. We've also started putting training on IMS Academy for new releases. So a lot of the new features that you will see in CR2 and 4.6 and 5.1.2, you'll see IMS Academy content on how to use those new features. They're not they're short videos, they're how-to videos. They give you a good idea of how to get started with any of the features we've done. So we'll be doing that more and more, and I encourage you to go to IMS Academy. And again, IMS Academy is certainly not complete. So if you have ideas of, how-to videos and things like that you'd like in there, please, either through the community or through the chat or through, direct contact with your Broadcom person, then please reach out and let us know. So with that, unless there are any questions, Gary, I'll hand over to you for the Zero to Cloud Hero training. Thanks.
Thanks, Aaron. So today, as Aaron mentioned, we're going to be covering a very, very simple introduction to deploying the container gateway in Docker and Kubernetes. So for this, we're not going to be talking about any kind of templating language. So we're not looking at Helm, we're not looking at Customize. It's going to be as simple as possible deploying the gateway. You want to have a development environment up and running in one of the two variants. So we'll show you how to do that. We'll start with a very simple comparison between Docker and Kubernetes. Again, very, very high level. We'll then go into Docker. We'll deploy the gateway using Docker run as the simplest method, and we'll then take a look at Docker Compose. So we'll then move into Kubernetes. So I know we currently have gateway Helm charts, and in the community site, we also have a Layer7 operator, but deploying the gateway in sort of plain text YAML is something that we haven't touched on in quite a while. So I'm going to show you what that looks like from a very simple perspective, and you'll be able to deploy the gateway in the same way. To do that, we're going to need a Kubernetes cluster. For that, we're going to use Kind, which allows us to deploy a local Kubernetes environment. So we'll also deploy that as part of this. And we'll deploy MySQL for the gateway to have a MySQL database, and we'll also deploy the gateway. So when comparing Docker to Kubernetes, what we're actually comparing is container orchestration, not container runtime. I'm not going to be talking very much today at all about Docker Swarm. Docker Swarm is the container orchestration engine of Docker, or container orchestration platform of Docker, and Kubernetes is also a container orchestration platform. The container runtime in both contexts can be Docker. So just bear in mind that when comparing the two. So Docker, as we'll see today, is really easy to use. Functionality is built directly into the Docker engine, and it's really great for fast deployments and simplicity. So if you want to get a gateway or some other application up and running pretty quick, Docker is a great tool to use to do that. The problems with it, though, is that it doesn't scale very well and it has lower levels of flexibility. So that makes managing production environments as they scale both in complexity and size significantly more challenging to manage over longer periods of time. Kubernetes, again, as we'll see today, has a much steeper learning curve. It comes from Google's Borg platform. Google's been running containers in huge scale in production for over a decade, and that comes with a wealth of trial and error of running at that scale. Kubernetes also has a wide variety of enterprise critical features, and that makes it a clear winner for most organizations when they're comparing the two to use in production. And it also has a bigger open source community with more options for customization and flexibility. So the environment that we're going to be running today is currently running on a virtual machine, on an Ubuntu virtual machine. If you wanted to take a look at this afterwards, then you can use Docker Desktop. So Docker Desktop is free for personal use. If you want to use it in any kind of business context, then there are licenses associated with that. But standing up a virtual machine and running it on top of that is absolutely fine as well. The repository that we'll be going through today will be available on the community GitHub site in the near future. So you'll be able to go through all of the steps that we go through today if you want to get a gateway up and running. So we're going to start with just using Docker run to deploy the gateway. When I go into the development environment, I'll show you what each of these commands, what each of these arguments are doing, and I'll give a bit more context as to what we're actually doing with that. After we've done that, we'll head into using Docker Compose. The Docker Compose file basically gives us the same features as our Docker run command, but it gives us a file that we can use to organize everything nicely, so that if we want to go back to it later on, we can do that without having to store a really, really long command. In both contexts, we're going to need Docker. For Docker Compose, we're going to need to use the Docker Compose plugin, and we're going to need a gateway 10.x license file. For anyone that has experience with Docker Compose that's used it previously, you'll note that there is a docker-compose command that you have to run. Docker Compose is now part of the Docker CLI, so you just install the Compose plugin. So, starting with option 1 of Docker run, we're going to be running this gateway without a MySQL database. It's also referred to as ephemeral mode. The Docker run command, we're using the RM flag. That basically means that when we're done with this, Docker is going to stop the container, and it's also going to remove it. So we don't have to run any removal commands afterwards. The -p is shorthand for port, and 8080 is going to be exposed on a local machine, and we're going to be targeting 8080 on the container. These are the default ports for the gateway. So we'll do 8443, 9443, and 8080. There's a couple of volumes that we're mounting here. So -v is shorthand for volume, and we're going to be exposing RESTman. So that's going to be enabling the RESTman service. We're also going to load in the gateway 10.x license to the Bootstrap location on the gateway. And we're also going to be loading in a Hello World bundle. And that's going to allow us to test our deployment once it's up and running. We're also passing through some very basic environment variables, so SSG cluster host, and we're passing in a username and password that we'll use to connect in to, through to Policy Manager, or we can use them to manage RESTman. So running this command is going to give us a very, very simple gateway that doesn't have any persistence associated with it. And if we run on the side here, docker ps -a, we can see there that we've got a gateway up and running, that we've got a gateway up and running. When that's available, it's going to be available on 8080 on the host and 8443 and 9443. I'm running this container without the -d flag. If I add the -d flag, then it'll run in the background. Otherwise, it just runs, and I've got access to standard out and standard error here. To view the logs for the Docker gateway, obviously they're on the screen here, but if I wanted to view those logs, I can do docker ps to grab the ID of the container, and I can just run docker logs, optionally with -f to follow the log output, or just the ID of the container, and I get the log file back. So very, very simple. And the next thing we'll do is just quickly test to make sure that this is working as expected. So we have the Hello World bundle that's been provisioned there. So we can curl HTTPS, and we can go for the IP address of this virtual machine, or localhost, and we'll target 8443, and we'll just hit Hello World. We'll also pass through the -k flag because we're using a self-signed certificate. And we get back a response, which is very simply Hello World. So if we do now a watch docker ps -a, we can run Control C to shut down this container gateway. That's then going to remove the container image as well. So this is really helpful if you're just looking at getting a dev environment up and running pretty quickly, and you just want to test something out. You want to test out a RESTman bundle. You want to see if a policy is going to work. You want to import something. That's going to be really handy for those use cases. If you do want to add persistence, then I would say the best option for repeatability is going to be using Docker Compose. But if you did want to stand up a MySQL database using Docker Run, then you can do so with the command here. And you've also got the option of running a gateway that's going to connect into that MySQL database as well, with some additional configuration added in here. So cluster password and some database information that the gateway will need to connect into that. So the next thing that we'll do is take a look at using Docker Compose. So this is going to be very similar to what we just did. The difference being is that we've got this Docker Compose file here. So the Docker Compose file is going to mirror very, very closely to what we had with the Docker run command. We've got the same ports exposed locally and exposed in the container. And we've got similar environment variables. In this case, we do have the database user and the JDBC URL because we are going to be deploying a MySQL container as part of this as well. So the configuration for both Gateway and MySQL is configured in the same place. We're also going to be exposing a RESTman, and we're also going to be passing in the license file and that Hello World bundle so we can make sure that everything works. In this context, we're loading in that license as a file on the gateway in the Bootstrap folder. If you wanted to load it in as an environment variable, you would uncomment this, and you would add this extra Java argument, which allows you to use the license as an environment variable. So very simply, if we just do docker compose up -d, that's going to bring up MySQL and the gateway, and we can see here we've got two containers starting up on the side there. We've also got this MySQL folder with all of our database information. So what this gives us is a container gateway that does have persistence on our local file system. So if you wanted to use this for quickly developing something and then exporting it as a RESTman bundle, or just some local policy testing, that's going to be quite useful. Also, having this local file persistence means that if you don't want to renew your gateway all the time and you want to bring it down, then that's going to be something that you can do fairly easily. What we've also got configured in this file here is just some very simple resource reservations and limits. So this says that we need to have 2 gigs available and 2 cores for our gateway at a minimum, and the maximum that it can go to is 4 gigs of memory and 4 CPUs. We can also check the usage of that by running docker stats, and that's going to show us the CPU usage and the memory usage of our container gateway and MySQL. And finally, we can confirm that everything is working as expected by just running that curl command again against the gateway that we've just deployed. And we've got hello world back from this gateway. We could also at this point sign it through Policy Manager. We'll save that for the end when we deploy this into Kubernetes. So to bring this down, all I have to do is run docker compose down. And again, it should also remove any stopped containers for us as well. So docker compose down. But notice that the MySQL folder with all of our database information, that's going to remain. Now, this isn't something that we would support or recommend doing in production. But from a dev perspective, if you just need that environment up and you want some persistence so you can do stuff like restart the gateway for loading additional stuff in, then this is a perfectly fine dev thing to do, dev environment thing to do. So that is a very simple way to start the gateway using Docker. So we've gone through Docker run and Docker compose. Are there any questions on that before I move on to Kubernetes?
Hey Gary, one thing. How did you get the bundle? Do you want to cover that?
Yeah, sure. So getting the bundle. So in order to get the bundle, you would use the RESTman API on the API gateway. So the endpoint for that would be, so I'll just type it here, it would be RESTman 1.0 bundle, and then you would, so bundle, and then I think it's, you can go for folder.
Okay. So it's just any RESTman bundle that you have exported?
Yes. Yeah,
Cool.
exactly. So any bundle that you have, you can load that into the Bootstrap folder on the container gateway.
Brilliant. Thanks.
Thanks, Aaron. So the next thing that we're going to cover is Kubernetes. So again, this is going to be very high level, so we're not going to go into all the things that Kubernetes does. But in a nutshell, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. So it's a container orchestration platform. So in order to do the Kubernetes component, the Kubernetes side of testing today, we're going to be using Kind. So Kind is something that will allow us to provision or deploy a local Kubernetes cluster. I think Kind was originally or primarily designed for testing Kubernetes itself, but it also gets used as a continuous integration tool, and it can also be used for development. I've put here a couple of ways that you can install Kind. There's more ways that you can install Kind if you head over to their documentation. But if you're running on Mac OS, then you're going to run brew install Kind. And if you're running on Ubuntu or a Linux variant, then you're just going to go through and grab the Kind executable and save it to your local path. To create a Kind cluster, it's very simple and it's also very quick. You're just going to run Kind create cluster and then pass through a name. In this case, we're going to call it Layer7. And then to delete the cluster, it's going to be the same command, just with delete instead of create. So to deploy the gateway in Kubernetes, there's a couple of prerequisites. We'll need Kubernetes. We'll also need kubectl. Kubectl is, or kubectl, as it's also called, is a command line interface for interfacing with Kubernetes, and we'll also need a gateway 10 license file. So as mentioned, Kubernetes is a lot more complex than Docker, and it has a much steeper learning curve. So we do have, so if we contrast what we have here, which is essentially 6 files, compared to what we had with Docker Compose or Docker Run, there's a lot more that you need to to have a deployment running successfully in Kubernetes. But it does offer a lot more flexibility in the way that you can configure those and so on. So for this, we'll be running kubectl apply, and we'll give a path to MySQL. This MySQL folder here, which will create a deployment, a persistent volume claim, and a service. And we'll also do the same for gateway, which will create a config map, a deployment, and a service. And we'll then configure port forwarding so that we can access this gateway on 8443. And we'll also sign into Policy Manager in that. So if I expand Kubernetes, and let me just open up this in preview. So the process that we're going to go through here is fairly simple. We're going to run that kind create cluster command, and we can also run Docker PS in the sidelines there. So kind runs as a Docker container, and the install process is very quick. So this is gonna run Kubernetes 125.2, and you can see there we've got a Docker container with kind running there. Once the control plane started, then we should have a Kubernetes cluster ready to start interfacing with. And we can do kubectl, well, we'll just run that command there. So kubectl cluster info. And we can see there we've got a Kubernetes up and running that we can start accessing. So to deploy MySQL, I'm going to kick this process off now, and then we'll take a look at what's in each of these files or folders. So from a gateway perspective, we've got a deployment.yaml. So this deployment is part of a standard schema that Kubernetes has, and what this represents is a desired state. So you send your desired state and configuration to Kubernetes, and Kubernetes has controllers that picks that up and turns that desired state into reality, which in our case is going to be running the container gateway and running a MySQL container as well. So this deployment schema is going to be the same across the gateway and MySQL and any deployment that you have in Kubernetes. Something important to note here is the update strategy. So Kubernetes has a claim on zero, no, or low downtime. And the way that they do this is through rolling updates. So at the moment, we have one gateway replica. That is the desired state for the number of replicas that we want. And we've got a strategy of type rolling update. This is the default update strategy in Kubernetes. And what we have here is a max surge and max unavailable. So the max surge is 1. That means that if the schema, if this schema changes, or if this object changes, this deployment changes, then a maximum of 1 gateway can be added. So for a short period of time, you'll have 2 replicas running, and the max unavailable is 0. So no gateways will be removed when an upgrade is happening. So if you had 10 replicas and the max surge is 1, then you would go through to 11 replicas for a short period, and gateway deployments would be replaced one by one until the entire upgrade had taken place, all while maintaining a minimum of 10 gateway replicas. So something else that we have here that's quite important is the selector. So the selector tells the Kubernetes service that we're going to deploy as part of this as well, which gateway pods to load into the load balancing pool, and that works with this app here, with this label here. The container configuration is also quite similar to what you would have with the Docker Compose file. So this is the actual container definition here. We've also got a name of gateway. We have the image. We have stuff like image pool policy, resources, so requests and limits. This tells the scheduler. The minimum required to deploy this container, and this tells the scheduler the maximum before the container is removed due to out-of-memory errors or others. We're also defining ports here. These ports allow the service to interact with the container, and it also allows for the networking to go through correctly. We've got the same volume mounts. It's a little bit different with Kubernetes, but basically we're going to be mounting a config map that we'll take a look at in a bit. It just contains the same bundle that we looked at earlier, and we're going to be mounting it to the Bootstrap directory on the gateway. We've also got some environment variables. We're using the SSG license environment variable in this context as well. And I've kept this as simple as possible. We could split these out into additional config maps and secrets, but for simplicity's sake, I'm just including everything into the same deployment. So in this, we've also got a liveness probe and a readiness probe. These tell Kubernetes when the gateway is ready to start accepting requests, and it also gives you a chance to determine whether or not the gateway is healthy before actually opening it to the outside world for traffic. And finally, we've got the volumes here, which correspond to the volume that we mounted earlier, or the volume mount that we had up there earlier. So a lot more complex than just using Docker Compose, but a lot more flexibility added into that. The gateway service that we'll be using today is of type load balancer, and we're exposing the same ports that we exposed through the Docker Compose file and the same ports that we just saw in the deployment YAML. And finally, the config map, it just has the hello world bundle, and that's loaded in as a key value pair. So that's going to be loaded in as a file in the Bootstrap directory of the gateway. So now everything is up and running. We can do get pods. We can see that we've got 2 pods that are both in a running status. So those are ready to start accepting requests. So there will be some differences when interfacing with this. We're not going to be binding directly to the host in this context, as we did with Docker Compose. For this, we need to have an external IP provisioner available in this kind cluster. So we don't currently have that. So the way that we'll get around that is by using kubectl port forward. There are ways, if you're interested in installing or configuring kind to use an external IP provisioner. But for most cases, if you're doing this on a local machine, using port forward is something that's going to be more than adequate. So I guess the first thing that we can do is a simple curl to make sure that everything is working as expected. Or before we do that, we have to do this. So what we're doing with this is kubectl port forward. We're setting the address to 0.0.0.0. This will make it available on all of the hosts' network interfaces. So that'll be available for us to access externally, and we'll use that to connect into Policy Manager shortly as well. So we can run this on the side here. So kubectl port forward, and that's going to give us access to run the curl command or the curl test. And again, we've got the hello world response that comes back from that. So what we haven't done on this gateway from a Kubernetes perspective, well, the only thing we haven't done is enable RESTman. What we might do though is connect into it through Policy Manager. This gateway does have that external MySQL database, so we can use Policy Manager to interact with it. All of the examples that are going to be available on this repository are all have the same passwords. So admin and 7-layer, you can configure that as you need to. But by default, we just keep it simple with that. This is the IP address of the virtual machine that I have running, and I can sign into the gateway that's running in this local Kubernetes client cluster, and I've got access to this hello world folder. So very, very quick and easy to do that. If I wanted to enable RESTman, I could do that as well through my deployment file. And if I wanted to interface with this through RESTman, test some things out, that's all stuff that I could do with this environment. When you're finished with that environment, all you have to do to remove kind is very simply kind delete cluster, and I'll just pass through that name that we gave it, which is Layer7, and it's going to delete that cluster for us. And if we do Docker PS, then everything has been removed and is gone. So with that, we've gone through a very, very quick example of how to deploy the gateway in Docker using Docker Run and using Docker Compose. And we've gone through a very quick example of how to deploy the gateway in Kubernetes, deploy a kind cluster, and deploy the gateway in Kubernetes. Are there any questions?
Hey, Gary, this is Kaushik from Assyrian. I do have we are setting up the same similar kind of cluster in our Arc. But one question I have is how do we set up the licenses as secrets instead of config maps? And is there a way can we not check that code into source repo so that people cannot misuse it? So is there any way?
Yeah, sure. So I think for that, the Helm chart has the license stored as a secret by default. The alternative would be, if you didn't want to have to check that into source, you can also create a custom image of the gateway or derived image of the gateway that has the license baked into it, so you don't have to include it. And the alternative to all of that is to use an existing secret for the gateway license. So that's something that you would configure through the Helm chart. There's a section for existing secret for the
Okay.
license file. So you create a license in Kubernetes up front, and then you deploy your Helm chart, and all you're doing is referencing that.
Right. But what I was looking at the Helm chart, but I was thinking more of a use customize instead of Helm to fit our org needs. But I was thinking, how can we get that secret converted and stored somewhere in PIM vault or somewhere to retrieve whenever needed. But I like the idea of making it as custom image and then use that as a source.
Yeah. So if you're looking at using Customize to do that, then Customize has a secret generator.
Right.
Yeah. So you can have secret generator, and then you generate the license from you generate the license from file. The one thing with Customize, because of the way that we reference license in the Helm chart, you'll have to specify license without any extension.
Okay. I think I got confused. Yeah.
So there's also an example in the there's an
The
example
repo?
of that in the community in the community repository. So I can pop a link to that in the chat quickly. Let me just find one.
Yeah. That helps. Yeah.
So it won't be there. It should be in this. Integrations. And if we go into this one, there is a customized folder here. So this generates the SSG license, and it takes in a file called license with no extensions. The reason it's license with no extensions is because of the way that it's referenced. But you can use that as a starting point. So you would drop, license in this folder, and then it would create that. And then from a Helm perspective, you would have the license used with the existing secret name.
Right. Right. Yeah. This is what I referred. Yeah. But I looked at the secret generator. Yeah. Can you please share me this link? Yeah. Thank you so much.
Yeah, sure. I can drop that on the chat quickly.
Yeah. So
And sorry.
one follow-up question. I'm so sorry. Yeah. So the one follow-up question is it's bit generic question or like a decision based. We are using the public cloud, one of public cloud, and we were thinking whether to go with the ALB or an NLB solution as an ingress. Because if we use ALB, that will straightforward give us an request or access to the cluster. But if we use NLB, we won't be doing a two-way SSL with that, right? So what would you propose in that scenario?
So referring to AWS, I'm not aware of the specific differences between their ALB and NLB.
Mhm.
I guess it depends on the use case, right? So if you're looking at having direct layer 4 access to the gateway, then
Mhm.
you'd want to deploy the gateway with with a layer 4 load balancer.
Mhm.
The alternative, if you just want to serve HTTP and HTTPS traffic over the gateway, then having an English controller upstream is what is what a lot of customers do. Um, and in that case, yeah, you wouldn't have mutual TLS between a client
Yeah.
and the gateway in that context.
Mhm. In our
What
traditional gateways, we have this mutual TLS between the gateway and the clients. But if we use any of the cloud load balancers, they all terminate at the layer 7. So we are just what would be the best
Yeah,
solution? Yeah.
yeah. So most English controllers do. There are some English controllers that do support SSL pass through. I know Nginx is one of them. So you can configure pass through on that. Enabling pass through for ports outside of 443
Mhm.
becomes a one-to-one mapping. So that is a limitation to be aware of. But if you had an English controller like
With a one.
Nginx and you
Mhm.
configure pass through, then you should be able to maintain the mutual TLS between your clients and the gateway.
Okay. Okay.
Um, yeah. The other option is just deploying the gateway directly as a layer 4 load balancer, and then you would have that direct connection between client and that external IP address that gets routed to.
Got it. Yeah. Makes sense. Makes sense. Yeah. Yep. That's all I have. Thank you.
No problem. And
Hey,
there's a question. Sorry.
I was going to say thanks for the questions, and I think there's something in chat as well.
Yeah, I was just looking at that. So setting up using Helm is part of the next office hours. Yeah, so going into Helm and going into, I guess, a basic look at Helm will be one of the next sessions, and then we'll kind of get further and further into more detailed deployment options. So there's a variety of things or ways that you can deploy the gateway with different configuration options. So we'll get more into that detail in future sessions.
And like we said, Gary, if there's any ideas or topics or specific things that people want to talk to, then yeah, feed us that information however you can. Okay, any other questions for Gary or anyone else on the team?
Yeah, I do have a question. I've tried to play with this before. And my question comes in like, what if I wanted to add like extra add-ons like OTK or the mobile stuff?
Yeah, so from a Docker perspective, that's Docker is what I know. So I used to be in the field team. If I was standing up a demo environment that I needed to test something in, then Docker Compose would be the route that I'd go down for that. So from a gateway perspective, installing OTK, you can have you can install the OTK headlessly. Sorry. So if you have you can write a script to install the OTK directly onto the gateway using RESTman. And then you can also use the same MySQL server to create the OTK database and load in all of the the OTK database schema to that. The alternative to the headless method is just using Policy Manager, connecting into it, and installing the OTK there.
Okay, cool. So I mean, as long as you have, I guess, persistent storage, then you wouldn't have an issue, if the container restarted.
Yeah, yeah, that's right. So the headless method, I guess you could probably install the OTK, but yeah, to your point, if you restarted it without persistence, then you'd lose the OTK.
Okay. All right. Yeah. It just looked like you guys had, ran into some repos or something. It looked like you had started because we use Kubernetes, so Docker doesn't really work for me. And it looked like you'd started doing something, but it wasn't quite finished. So I don't know.
So I think that might be reference to the gateway OTK chart.
Yes.
Yeah. So that started as an internal project, and that wasn't carried on because of the way that we were installing OTK. It didn't account for upgrades, and it wouldn't be as useful in that context. So that also uses the headless install method. So if you wanted to have a sidecar, if you wanted to have a deployment that ran a script that installed the OTK, then you'd be able to do that. We are also currently working on updating that example to include something that does work for provisioning the OTK onto a container gateway with the Helm chart.
Okay.
How do we ensure that MySQL instance is not a container in case we want everything else to be container? So I think one of the questions that our customers have asked is MySQL is a container, is a persistence. It goes away, then everything goes away, right?
If you have a so it depends on the type of volume that you have. So in the Docker context, this is a file system. So unless you remove the file system, it's not going to go away. In the context of Kubernetes, if MySQL is a deployment and it has a persistent volume associated with it, then yes, when you remove the deployment, it's also going to remove that volume. So you would lose it. You can use in Kubernetes a stateful set, and that won't implicitly remove the persistent volume claim when you remove MySQL. So you'd be able to connect back to that persistent volume claim, provided that you have the correct credentials to do so. There are also other database technologies out there that have more robust and resilient container versions of container variants of MySQL 8. And the recommendation that we have in cloud environments, if you're running in AWS, Azure, or GCP, so Google Cloud, would be to use the relational database services that they provide, and that gives you the ability to run databases in multiple zones. You can have, I think, in most of them configured for daily backups, and they also allow you to scale the storage. So if you ever needed to increase storage, you can scale that dynamically.
And in that instance, in case of failovers, the gateways containers need to be reconfigured to point to the failover instance somehow.
So with respect to the cloud vendor, with respect to the way that cloud vendors do it, you would have one endpoint for the database, and they would load balance traffic to the rest of the nodes.
All
I
right,
think if
thank
you did configure like a secondary, then you would need to alter the connection string for the JDBC URL. But that would just be done in the configuration. I think we have examples in the values.yaml of the gateway Helm chart if you wanted to configure primary and failover.
Okay. I think when it comes to on-prem, we are more limited to what we can do, right? For MySQL.
Yeah, I mean, it depends on the way that you deploy MySQL, right? But yeah, if you're looking at a traditional OVA deployment, then we do have the documentation for primary and configuring primary and failover and so on.
All right, thank you.
Does anyone else have any additional questions about the demo today, or just anything Layer 7? Any questions?
I have a question around kind of the shutdown management for the Kubernetes containers. So if we were to scale up to a certain number of replicas and then scale down and we had live traffic going, what is the general behavior on the shutdown process? Does it respect any ongoing traffic or threads, or is it just shutdown based on an auto-scaling parameter, or you manually doing it yourself?
Hey, Nathan. Yeah, so that's something that I'm going to be looking into more over the next couple of days, just to see exactly what the implications are of having a gateway that's replaced. So, I mean, from a Kubernetes perspective, there is a default termination grace period. So the gateway would have by default 30 seconds to close off any connections. As to whether or not the gateway respects that, that's something we need to do a bit more research or a bit more work to identify exactly where the to identify the kind of exact behavior of that.
Sure. Thank you. Appreciate that.
I had a question regarding rate limiting. How is rate limiting implemented now if we have multiple containers?
So on the container gateway, we have an embedded Hazelcast that runs. That Hazelcast is where the rate limit counters are stored. In Kubernetes, the gateways would cluster with each other, and the information would be stored there. So when you have a MySQL back gateway, you have nodes stored in the gateway database, and that's used to track the location of the gateways for Hazelcast interactions. So you would have cluster information stored there, and that would give you I guess like somewhat of a cluster-wide rate limit and throughput quota. If you're running with the ephemeral gateway, so gateway without a database, then what you do is externalize Hazelcast, and each container gateway will have the same configuration connect into that Hazelcast, and Hazelcast will handle the sort of clustering of gateways. So you'll have persistence across those different states of counters and rate limits.
So does this need to be enabled, or how does it automatically takes effect when gateways are deployed as containers?
So by default, if you're deploying a gateway that's backed by MySQL, then the embedded Hazelcast is always running on that. The same is true for the appliance gateway. It has the embedded Hazelcast running. If you want to externalize Hazelcast, then in the gateway Helm chart, there's an option under Hazelcast where you can turn that on. You can either deploy the Hazelcast subchart, which is part of the gateway chart, or you can use an external Hazelcast that you've deployed separately. But the configuration is in the Helm chart. If you're looking at that from an appliance perspective, then we have documentation on. There's a couple of files that you have to add in to the appliance gateway.
Gary, I'll just add to that question. So I just had this conversation with engineering yesterday. It's a little more nuanced. For rate limiting, the actual rate limit is always maintained on each gateway, and that's true for our container. Any of our gateway form factors, including the container gateway. What gets shared across a cluster of gateways, either using the database or with the Hazelcast, is how many gateway nodes are participating in a cluster, so that they can divide that to simulate a cross gateway rate limit. Our throughput quota assertion, on the other hand, does share a incremented counter across a cluster, again, either using the database or Hazelcast, depending on your configuration. And so that's a difference between rate limiting and throughput quota in the context of database or Hazelcasts with or without containers, to be exact. Another thing I just want to throw in there to this group, especially around the question about, what happens when the database goes away. What Gary's showing today, what we plan to show over the next few office hours, is sort of, an introduction to containers using Docker, Kubernetes, with or without Helm, and kind of the direction we're headed with our optimal cloud deployment strategy that is focused on containers and Kubernetes as our least common denominators, and being more cloud native and allowing our customers to scale beyond traditional limits and take greater advantage of services in the cloud. We still recognize that not all of our customers are there, and some might never quite get there. even if they do want to move to the cloud. Their definition of that is more of a lift and shift of their existing layer 7 deployment to a cloud, but still deployed in a very traditional way, backed by a MySQL database. And we're going to make allowances for that too. So, you know, the idea of having a database backed gateway is not going away. We're just focused on other alternatives that can optionally remove the database, which is otherwise always going to be a bottleneck for scale at some point, and allow you, our customers, to choose what will work best for you. Does that make sense?
So Ben, I have a follow-up question, is that if a customer takes their clustered gateways on-prem, deploy them as sort of lift and shift, not doing containers, but sort of as the first step, they deploy them as AMI images.
Yep.
But they're not clustered. They're individual instances.
Yep.
Are they able to get the same features, rate limiting and whatnot?
Well,
if the gateways are not in cluster, it looks like they're not.
No, I mean, so there are certain features that, you know, only work the way they do today if you have a database backed cluster of gateways. We've long had customers, you know, deploy single gateway clusters, which is the idea of every gateway having its own database, not sharing a database across a cluster of gateways. And that's let them scale up to much larger clusters of gateways without hitting a shared database bottleneck. But then, you know, they've had to find alternatives for those database-backed cluster features. As we move to this database-less cloud deployment strategy, we are going to be looking for alternatives for all of those things so that we can hopefully give you feature parity across what we're going to eventually be considering logical groupings of database-less container gateways running across zones, across regions, across clouds. And part of what we're at the beginning of doing right now are identifying those gaps that we may need to fill with, you know, just alternative ways of doing things or product roadmap to give you that feature parity. But to answer your question, no, you can't just lift and shift a database-backed cluster of gateways from on-prem that you're using in certain ways to the cloud, but not cluster them with a shared database and expect to have all the same features. On the other hand, you can still cluster them in the cloud, and we would normally recommend you point them to a MySQL compatible cloud database service to get, you know, high availability and other qualities of service that those provide for a database-backed cluster of gateways. That would be probably our recommendation for a customer that wants to lift and shift and still have a database-backed cluster of gateways running in the cloud.
So if we do a lift and shift individual instances with a shared database, does the rate limiting recognize that? Because it's not logically clustered.
So rate limiting, again, back to that point I made earlier, and this I just confirmed with engineering yesterday, has never really shared its current rate limit counter across gateways, even in a database-backed cluster. What it has done is shared its awareness of how many gateways are actively participating in a cluster. And then depending on how you configure your rate limit assertion, if you say you want a rate limit across the cluster, it just takes the rate limit you specify in the assertion and divides it by the number of active gateways. And then each gateway is keeping track of and enforcing that number, not a shared number across the cluster. So, and that's unlike the throughput quota assertion, which does maintain a counter that does get locked and incremented and shared across a cluster.
And that's
So
what I'm trying to. That's what I'm trying to understand is that if the gateway is running as AMI images, like say 8 of them, but they are backed by shared database, is the rate limiting going to recognize that there are 8 active gateways
yes, if they're backed by a shared database, yes, because those gateways will report their status in a cluster info table inside that shared database. That's what gateways that have policies that use the rate limit across the cluster look at, so that they can divide their configured rate limit by that number of active gateways. So yes. Now, if they're not sharing the database, then no. And the embedded Hazelcast does not solve for rate limits shared across a logical grouping of gateways that connect via embedded Hazelcast. They would only do that for external Hazelcast.
And this is something that's Gateway picks up on its own, that it recognizes there are 8 active instances as we scale up or scale down, or
with database backed gateways, yes. As you scale up, scale down gateways that join that cluster and report their status in the shared database, yes, every gateway in that cluster picks up the changing status of active gateways in the cluster to constantly adjust the math of the rate limit assertion.
All right, thank you.
Yeah. Sorry to take you off track, Gary. I did want to put out there, though, that this is all part of a unfolding cloud deployment strategy that has our focus over the next year. And what Gary's really showing you is sort of the nuts and bolts of where our optimal cloud deployment strategy is going around containers and Kubernetes, using Helm charts and other mechanisms to solve for a lot of these problems. But we do plan to continue to consider all of our customers and where they're at on that journey. And we do expect some customers to just want to lift and shift and run Layer 7 in the cloud in a more traditional way. Ultimately, though, you'll be making choices. You're not going to get everything that we can offer, that cloud can offer, if you just lift and shift and run in a more traditional way. But you'll still be able to do that.
Thanks, Ben.
Okay, so
sorry.
I have a question. Sorry, I joined late, and my apologies. But I think this whole conversation is around the deployment, Kubernetes container deployment and whatnot. How is it different from the previous sessions we had? And my second question is, when you showed that Hello API, did you deploy part of this deployment, or was it like did you have to create after you deploy the container?
So this is different to previous sessions. So I think previous sessions we've touched on deploying the gateway using the gateway Helm chart. And I think we've also covered a session before around the portal Helm chart maybe. This is taking that back sort of a level and just talking about deploying it to, so using Docker and deploying it using the kind of base, the kind of bare minimum. So not using Helm, not using any kind of templatization, just going with sort of basic deployment files, config maps, and service. For the Hello World service, that is a bundle that was exported from running gateway using RESTman. And that's included in this example as a config map that gets mounted to the correct place on the gateway for Bootstrap. And in the Docker example, it's the same thing. It gets mounted to the correct place for the gateway startup.
Okay, so I see. So you kind of exported the XML version of that into the YAML file. Okay.
Yeah, exactly. So it gets it gets stored as like a plain text file, and then it gets mounted as a file. Plain text key value pair, and then it gets mounted as a file.
Now, as I'm installing the gateway, all of my mappings and dependencies are I guess they wouldn't be fixed, right? Like, I mean, I still gotta fix that first or install that first through one of the YAML files and then deploy this.
So mappings and dependencies with relation to a bundle, is that?
Correct. Yeah.
Yeah. So the bundle that goes in, it kind of depends on the way that you're running a gateway. But if you're bootstrapping a bunch of policies to a fresh gateway, so a fresh or an empty MySQL database, then you won't have any problems with existing references and so on. If you're importing to an existing gateway that is database backed, then I would say the best option for that would be to use the GMU or RESTman directly. So you're looking at bootstrapping things that you might use commonly, like cluster-wide properties. You might have some standard services that you want to deploy. But if you're looking at running a database-backed gateway and administering that over a longer period of time, then you'd be able to continue using your existing tool chain. So if you use RESTman or the GMU in your current appliance gateway, you'd be able to continue using that in the container gateway.
Yeah, I think that's the hardest part, I think, in the migration. But everything else is quite easy. But the GMU and the RESTman is the most painstaking and the time-consuming piece. But I get your point.
Yeah, I mean, there's also the option of cloning the database and migrating that into the cloud environment. That's one potential option. And then, yeah, from a RESTman or GMU perspective, it would be doing an export all and then importing that into the new environment.
Okay, thank you.
Thank you. There's also a question from Sebastian for Ben.
Yeah, I was actually just going to respond to that in the chat. Is this we're not in a position to choose the cloud provider, and you're especially interested in Azure cloud best practices with key vault network security groups delegations? I guess let me just respond directly then, as opposed to finishing the chat. Totally get that, Sebastian. On our side, we're just not going to be in a position to quickly, if ever, give detailed best practices on every possible cloud provider or even container runtime in platform within those different cloud providers or on-prem that our customers might want to deploy Layer 7 in. So what we are going to be focused on is the least common denominators and then drawing boundaries around our product versus where our product can run and what other services our product can integrate with. And then building a reference architecture that makes choices to demonstrate how that can be done flexibly, but also how and identify where customers can plug and play their own preferred, solutions within that reference architecture. And then strive for best effort support statements across those many cloud providers and container runtime engines, right? So we can provide the broadest support to our many customers. That said, we would expect more specific guidance to emerge over time as we and our customers do this in more specific cloud environments and using more specific container runtime engines, right? We would expect to take what we learn, document it in the form of knowledge base articles, additions to our tech docs and whatnot. Now, the good news is if you are focused on Azure, that seems to be the cloud that's bubbling to the top across more of our customers, right? As opposed to like AWS or Google Cloud Platform or on-prem alternatives in, like OpenShift and Tanzu. And so if we selected one to build our reference architecture in and provide more development in testing against and documentation for and support for, it at this point is probably going to be Azure. Does that answer your question? As much
Well,
as
it helps a lot, yeah.
Yeah.
Especially the reference architecture gonna help us a lot. There's
Yeah.
going to be any
Yeah.
documentary about.
And again, with best effort support, that means there's going to be clear limits for how deep we can go in all of these different environments. But it still means we're going to try to support you. So if you start to have some problems with what we are proposing that are more specific to Azure, you know, we're willing and ready to roll up our sleeves and try to solve those problems with you. And if we are able to, then that becomes something that can get documented in a knowledge base article, go back into our standard tech docs, become an addition to our reference architecture in the context of Azure specifically, that sort of thing, right? But that's something we expect to unfold over time.
And can you say anything about that time period?
That's always harder.
Yeah,
This is kind of a big initiative that is becoming our focus and will hopefully consume more and more of our program increments in a more detailed roadmap that will unfold over the next year. Right now, our current program increment, at least as far as the gateway is concerned, is focused on getting our next major gateway release 11 out the door. That's been a big necessary effort. After that, we're going to be free to look at, you know, these things more. And these things are at the top of our mind, you know, getting most of our attention. But we're sort of at the beginning of it, just like we're finding many of our customers are at the beginning of it too, with 6 months, 12 months, 2-year roadmaps to get to the cloud together with us. I know some of you are ahead of us, and the good news is there's already lots of, you know, ways you can do that, and we have customers doing that, and Gary's largely showing you what some of those ways are today. So it's already very possible, but what we're talking about in the context of this cloud deployment strategy is stepping back, looking at it more holistically, and not just for the gateway, but also the OTK and the portal, and providing a more cohesive cloud deployment recommendation with the reference architecture, and identifying that roadmap and having a more specific plan to deliver on it. So that's what's beginning to take shape right now.
Okay, thank you very much, Ben. To try that is end of this year, we're trying to have a test environment in our Azure. So hope and see it goes well.
I hope so, and we'd love to stay close to that because we'll also learn from you, and that can shape where we're headed for sure. David, I saw you had your hand up. Did you have a question?
Yeah, I was just going to say that sounds good to hear to me. So I had a go just at following the instructions in the container gateway guides. I tried deploying the Helm chart to AWS and immediately fell into a hole that was AWS specific around actually standing up the database, and looks like I've got to configure some sort of driver there in AWS. So I think it'd be really useful to have just kind of like a getting started guide for each of the 3 major cloud providers, you know, Google, AWS, Azure, just to get people off the road with something that works. And then, you know, people can drill down further into the provider specific documentation to tweak and develop those detailed best practices. But at the moment, yeah, you need to sort of transition very rapidly from what's in the container gateway docs to straight into AWS or whatever it is to actually get things working, which is, it's a little bit time consuming to get things going.
Yeah, clearly. And I don't disagree. And we're looking at exactly that in the context of this larger cloud deployment initiative. But what you just described there sort of falls on the left side of that for customers that, you know, kind of want to lift and shift and get to the cloud, but use a cloud-backed database service, perhaps, as opposed to the optimal deployment strategy, which we think is going to lean towards databaseless. And for those customers on the left side still wanting to use, database backed container gateways, but in the cloud and a cloud backed service, we are more immediately looking for best effort support around all those cloud-based services with some additional documentation, like you said, around basic recommendations for their configuration. Again, the lowest common denominator there is still going to be MySQL compatibility, but there are differences across cloud providers. And then even with multiple options within some of them, like AWS, you just go with MySQL RDS, or you go Aurora, and what are the implications of those things? In the same vein, we're even going to look at best effort support statement for MariaDB with Galera clusters as a MySQL alternative to customers that, are going to stay on-prem or even would prefer to deploy and run and manage their own MariaDB Galera cluster in a cloud to back their container gateways. That's something we already do on the portal side. Is something we have to still put in place on the gateway side. And these are examples of recognizing that not all of our customers that move to the cloud are going all in on containers and database less. And we still need to consider more traditional options for them, but with some cloud benefits. So noted, David, and we'll try to have some just basic getting started documentation come out of that across clouds.
Yeah, that'd be great. Thank you. So would you say that you see having a persistent database as kind of a transitional step then, with an eye to?
I feel like it'd probably take us a very long time, if ever, for all of our customers to move away from a database entirely. So I suspect it's always going to be an option that we'll maintain and support for some of our customers. I just also see it always being a bottleneck for those customers to scale beyond clusters of a certain size. Our default recommendation today is still no more than 8 gateways in a cluster, though really even we've seen and other customers have seen, no problems running database back gateway clusters up to 30. But the database will always become a bottleneck at some point, well short of 100, much less hundreds of gateways. And that's the scale at which some customers want to run layer 7 in the cloud. So no, I don't really see the database ever going away entirely. I see it always sticking around as an option for customers that want to use it indefinitely. But, that it will always impose some limits that might not really be a limit for you. If you're a smaller customer just running a handful of gateways and you like the convenience of the database, fine. But if you're one of our bigger customers that's deployed hundreds of gateways and wants to be able to easily scale up and down hundreds of gateways all running in logical groups across regions, across clouds, then the database becomes a real problem.
Yeah, that's interesting. Thank you.
Yeah.
Ben?
Yeah.
I have a question outside of the presentation. I saw recent announcement with the gateways. We're taking down the Salesforce integration, SDK, or not the SDK, but it was like a solution you can compile on your servers. Is there also will be a plan to do more integration or provide like managed solution kit or something like that with the Salesforce integration on various clouds?
I don't know offhand. That's one that hasn't hit my radar during the short time I've been back. It's something I'd have to look into.
Okay.
All good questions, folks. Sorry to take us off track there, but I did want to step back and give you more a broad awareness of where we're headed around cloud deployment strategy, and in the context of what Gary showed you today and plans to show you over the next several office hours. That's more nuts and bolts, containers and Kubernetes 101, building up on top of that, showing you what's possible today. But we'll love to be hearing your feedback on what you're currently doing, what you plan to do next, by when, and we'll just keep sharing where we're headed as well. And I look forward to working with, some of you even more closely so that we can, take that journey together.
And that's a good place to wrap up for the day. This session was recorded. It will be posted up on Communities. Aaron and I are both traveling this week, and so it's going to be a little bit of a delay. It'll probably be this weekend before I can get it posted, but I'll make sure that I send out a tweet and and post it on LinkedIn once it's up and running. So thanks everybody for staying with us. I know we ran over, but I think it was great questions, and we will see you next month.
Thanks, folks.